latent profile analysis, from now on referred to as LPA, can be thought of as a probabilistic model for clustering or unsupervised classification. The goal is generally the same as cluster analysis, to identify homogeneous groups within a larger population. The main differences between latent class models, which is the umbrella over LPA, and things like cluster analysis, which is an algorithmic approach to clustering, are that the former obviously lends itself to more theoretical speculation about the nature of the clustering. And because the latent class model is probabilistic, it gives additional alternatives for assessing model fit with likelihood statistics, and better captures and retains uncertainty in the classification. Basically, LCA inference can be thought of as what is the most similar pattern using probability, and cluster analysis could be thought of as what is the closest thing using distance measure. So now I will run an LPA, attaching the data. The McLust package has to be used. It performs various types of model-based clustering and dimension reduction. It requires complete data, which we have. The next thing, this next syntax will standardize all of the indicators to better see differences between clusters with the scale function. NA is going to remove missing data. I don't have any here, but it would if I did. And then mutate all scale/scales is part of what standardizes the data that we have. The next syntax is going to plot the Bayesian information criteria for all of the models. It's called sad clustering because I'm sad that I have to do this. Now you can plot the information criterion for all the models. And here we have a graph. As far as I can see, this is kind of like, okay, so we see that 2, again, is the best fit, I think. I'm not, like, really sure how to read this, and I didn't really find a lot on the internet for how to interpret it. But here we have the information criterion on the side and then number of components. So it looks like 2 components is at negative 2000 BIC. I literally don't even know. But the summary function is going to show the top models based on the BIC. BIC is a fit index that can tell us if the solution we've chosen is the correct one. So summary BIC, now we have the values, okay, which kind of makes sense. Now it kind of makes sense given this scale right here. It looks like, so you're looking for the highest number here. So negative 1053, negative 1000. Okay, so it looks like EEI 5. So it's saying that there are 5 clusters with variable volume, variable shape, equal orientation, and ellipsoidal distribution. So we're going to use, okay, so that kind of answers this question of how to read this, I guess. So you see 5 clusters, and you go here, it's EEI 5. Okay, so that would be right there. Anyways, trying my best. The next part is specifying the model, which you do with the McLust function, which we already loaded in earlier. The G is going to be number of clusters. So I'm going to change that to 5 according to that. Then saving model 1 as an object is what this syntax will do. Now we can get a summary of the output to look more closely at it. Okay. The output is going to describe the geometric characteristics of the profiles and the number of cases classified into each of the clusters. So we have 48 cases in cluster 1, 24 in cluster 2, 12 in cluster 3, 24 in cluster 4, and 12 in cluster 5. BIC is one of the best types of fit indices, but it's always recommended to look for more evidence that the solution we've chosen is the correct one, so in other words, validating it. So we can also compare the values of the integrated completed likelihood criterion, which is ICL. ICL isn't much different from BIC except that it adds a penalty on solutions with greater entropy or classification uncertainty. So this can also be done using the Michelust function. Plotting it, it looks pretty much the same as it did before as far as the plot goes. Now we can get a summary. And those are the same too. Now we see that this gives us a different result than the, yeah, I'm not doing this because it doesn't work. Get a different result than the cluster analysis, the k-means clustering. So yeah, interesting stuff.